Alright, let's do some basic soldering. So I have a pair of wires here and an LED. I'm going to pull my soldering iron out here. Get this thing turned on. We just got to wait for this to heat up. Ah! Nice. So here's a couple soldering irons that I have, and they do get really hot. They actually melt metal, in fact. So just be careful of that. The one on the right here is nice fine tip. The one on the left has a pretty similar size tip, all said and done. If you look, they're almost the same size tip. For me, I use the one on the right here as more fine detail jobs, and the one on the left is my general purpose soldering iron. So the first and last thing you want to do with a soldering iron is tin it. So that means melt a little bit of solder onto the tip. This is going to act kind of like grease in a pan and transfer heat better to your solder joints. You may get to a point where your tip is not melting the solder very well. This is a pretty mild example here because I keep my tip pretty clean. When metal gets hot, it starts to oxidize. Oxidation does not transfer heat well, so you may have issues melting the solder. So how do you fix that? Well, what I do is I use this tip tinner. I'll put a link in the description so you can find it. This has some chemicals in it that'll help remove any of the oxidation and make sure that your tip is nice and clean. After you do this, you're going to want to run it through a tip cleaner with some brass or copper wire wool in it. Now that I have a nice clean tip, you can see the solder melts into it a lot easier. This will transfer heat to your solder joints better and thus give you a better joint. Let's do a super basic example here. This is some stranded wire with some silicone insulation. I'm going to get a pair of pieces. Now this technique can also be used on any through-hole component that you might have, like a resistor or an LED, or even a wire from a pre-wired SMD LED. So now that I've got these stripped, I'm going to go ahead and twist the wires together on both of these to make sure that they don't splay out while I'm trying to tin them. But always remember, if you're going to use shrink wrap, put the shrink wrap on before you solder it, especially when you're doing this on a model, because you're not going to be able to go back and put that on. It's also good practice to have a decent distance between your solder joint and the shrink wrap so it doesn't shrink while you're soldering. So let's do some soldering. So I'm going to grab my third hand. Not that one. There we go. So now these are set up in the third hand, I'm going to tin them. First, I'm going to put a little bit of solder on the tip of my iron. Then I'm going to put the iron onto the wire and push solder in from there. Solder has some flux in it, so this is going to help solder flow into the joint and wet it properly. For a good solder joint, the solder needs to flow or wet into the wires. Now for my method, I actually put a hook in the wire after it's been tinned. And I'll do this to the other side, and that way I can actually put some tension between them when I solder. This is really helpful to pull your wires away from your miniature so you don't melt the plastic while you're doing your solder joints. So I'm going to give this a little bit more time to heat up before I push some solder in here because this is a bigger mass and it'll take a little bit longer to heat up. And now that I have a decent solder joint, I'm going to pull this out of the third hand, see if I need to do any clipping, and it looks like I have a little bit of a sharp edge, so I'm just going to take some nippers and clip those off so they don't poke through the insulation. And once that's nice and smooth, I can actually pull the shrink wrap up and over these wires, and then we just need a little bit of heat to actually get this to shrink down and seal over these wires. You can use a heat gun, but with this small soldering iron, there's actually a spot right above where I put the solder that I like to use to actually shrink these down, and it works pretty well. Now that we have the basic concept of soldering wires or components to wires down, let's move on to soldering to a circuit board. This is a proto board from Adafruit, and it's basically set up for through-hole devices like this resistor right here, and it's set up exactly like a breadboard, so if you want to take a circuit that you've made on a breadboard and push it over to this, you can actually have a soldered version of that breadboard circuit. So I'm just going to solder two LEDs in series here. So these are the components that I'm going to solder to this proto board. The other piece of this is some bus wire. It's just wire without insulation that has a tinning on it already. And just like a breadboard, these two rails here as well as all of these lines are connected. So let's solder in the battery connector first. So you can go in through the bottom, you can go in through the top. The important thing here is to make sure that you're not pushing too far and getting the insulation through. Because if that's there, you're not going to get a solder joint at all. So I've decided to put these in through the top and solder it on the back because all of my other components are going to be soldered from the back anyway. So I put it in at an angle, making sure that the insulation is on the outside and not the inside of that hole. Now I'm going to put the iron on it, heat up the whole pad, and then push a little bit of solder into it. Then I'm going to take the solder away, wait a second, and then take the iron away. You don't want to pull the solder away and the iron away at the same time because you need some time for that solder to wet and for the flux to burn off. I'm going to do it one more time here just to make sure everything is happy. I wasn't fully satisfied with that solder joint. And I did the exact same thing with the black lead. Now here we come in with a resistor. Now resistors are not directional. It doesn't matter which way you put them in. So I'm putting this to the positive lead and onto this line here that I'm going to solder other things to. I'm going to bend the leads out so it holds itself into place. And again, I'm going to put some heat on the pad, add some solder to it, take the solder away, take the soldering iron away. We do the same thing on the next one over here. It'll probably take you a few to really get a feel for this, but once you start getting a feel for it, it goes really quick. Time for the LED. Remembering that the long leg is the positive leg, we're going to put that on the same rail as the resistor. I'm going to put the legs through and then bend them out from each other so it holds itself into place. And again, tin the tip, hold it on the pad, add some solder, take the solder away, take the soldering iron away. And I'm just going to do this to both sides here, and then I'm going to do this to one more LED. So here's all the resistors set up, and I'm just putting the LED in place. And I've sped this up because you've seen this at real time, probably more than you need to at this point. So once these solder joints are all good, I'm just going to clip off the backs here. Now we can pull out our 9-volt and see if it works. That's bright. So that's through-hole soldering. What about SMD soldering, or surface mount device soldering? With this type of soldering, we're using much smaller components, so we need much less time on there with the soldering iron, otherwise we're going to burn the LED with just heat. And for this I'm going to use some soldering paste. It's basically little tiny spheres of solder with some flux in it. Once both pads are covered, I'm going to put the LED in place. Then I'm going to come in with a soldering iron and just touch both sides until the solder wets into the pad and onto the LED. Just have to make sure we do that to both sides and then give it a test. We're going to take the same sized LED and go to the microscope. You don't necessarily need to have a microscope to do this, but for showing you, it's going to be a lot easier to do it on the microscope. So the process is basically the same. I'm going to use the same solder paste and just put a little dab on each of the tabs on here. I've taped all the wires down to make sure they don't move on me while I'm trying to solder. And now I'm just going to use my tweezers to guide the wires in place to make sure that they're not springing up on me. So I just need to come in with the soldering iron and just give it a little touch to both of these sides here until the solder wets onto the pad. Both sides got soldered, but the bottom pad here kind of strayed out to the side. So I'm just going to come back and reflow and push this wire in with the tweezers and then hold it in place while the solder cools to make sure that it's where I want it. Now that I'm happy with both solder joints, I'm going to come in with an X-Acto knife and just scrape away some of this excess flux. Once the excess is taken care of, I'm going to come in with some alcohol and then a brush. This is just a cheap brush that I have, and I'm going to brush away any excess flux. Flux can actually be corrosive, so it can kill your solder joint over time. Then we got to make sure it works. Well, I hope that's given you some insight on how to solder. The proto boards are really cool, but now you can start soldering into stuff like these cool effects boards, maybe an Arduino, do some surface mount like this guy here, maybe even do a bar of lights like this for some project that you're working on. I've put a bunch of links in the descriptions for stuff that I've used throughout this. Hopefully that'll help you out. If you have any questions, leave it in the comments, and thanks for watching.